Good afternoon. This is Dr. Rudra Pradhan here. Welcome to NPTEL project on econometric modeling. Today we will continue the topic bivariate econometric modeling. So, in the last class we have discussed detail about the structure of bivariate econometric modeling. So, the starting point of bivariate econometric modeling is that we must have two variables in the systems. Okay, let me highlight briefly what was our last discussions. So, for two variables x and y, then the bivariate models is represented as y equal to alpha plus beta x plus u. Okay. So, this is the basic format of bivariate econometric modeling. So, there are three ways we can represent these particular structures, and that is with respect to various data types. So, we have three different data setup. One is cross sectional analysis, second time series analysis, then penal data analysis. So, penal data is the combination of cross sectional analysis and time series analysis. So, now for briefly, if we will go by three different structures with respect to this bivariate econometric modeling, then obviously the three way representation is like this: y I equal to alpha plus beta x I plus u I. This is cross sectional modeling. Then similarly, y t equal to alpha plus beta x t plus u t. This is time series modeling, and y I t equal to alpha plus beta x I t plus u I t is penal data modeling. Okay. So, now we are not in a position to discuss all these things simultaneously. So, we start with a basic framework of bivariate modeling, that took cross sectional analysis only. So, now for cross sectional analysis, either we can represent the simple models like y equal to alpha plus beta x plus u, or you can write y I equal to alpha plus beta x I plus u I. Okay. So, now you make a look here, the entire structure of bivariate econometric modeling is represented here. So, this particular structures is divided into three parts. One is intercept, that is what we call it alpha, this is intercept, and this is slope, and this is residuals or error terms. Okay. So, now here the idea is that, so we have y equal to y 1, y 2 up to y n, all right. So, x equal to x 1, x 2 up to x n, all right, and u equal to u 1, u 2 up to u n, all right. So, now we have discussed the detailed constraints of this particular bivariate econometric modeling in the last class. So, now here we are assuming that there are n number of observations, and one of the interesting point of this bivariate econometric modeling is that both the variables must have same number of observations. If there is any shortcomings, then obviously bivariate modeling cannot be fitted. So, we are assuming that there are n number of observations, and that to y variables and x variables, and corresponding to u variables. Here y is dependent variables, x is independent variables, and u is the error terms, which is usually not captured, but means the variable which is not captured in the system will be represented in the form of u. So, now we are assuming that there will be a estimated model. So, y equal to y head equal to alpha plus alpha head plus beta head x. Okay. So, let us assume that this is the estimated models. So, this is the estimated models. This is the estimated models. So, put in other way, other different way. So, our starting point is y equal to alpha plus beta x plus u. So, this is two regression lines. So, let us assume that y head equal to alpha head plus beta head x. Okay. So, now obviously y equal to y head plus e. Okay. That implies e equal to y minus y head. So, what is this particular structures? So, now let us see here. So, this is the entire setup here. So, this is x series and this is y series, and this particular component is called as alpha. So, our movement of y head is like this. So, here y head equal to alpha head plus beta head x. So, now there are certain original points here. So, this is the estimated line. So, the origin true points are like this. So, the difference will be like this here. Okay. So, we have the difference like this, all right. So, now this is E 1, this is E 2, this is E 3, this is E 4, this is E 5 like this. So, now this E represented as the error term. So, that means when we fitted a line, then obviously that is different from the true points. So, the true point and the estimated line, so it will give you or it will give the signal of error terms. So, now if you will further elaborate this particular equation, then obviously E equal to y minus y head is here y head minus alpha y minus y head. So, that is alpha head minus beta head x. Okay. So, E equal to y minus alpha head minus beta head x. So, here we have two objectives. So, here we have two specific objectives. We have two specific objectives. What is this objectives? First objective is to get the alpha head and what is the actual value of alpha head and what is beta heads. Okay. And second objective is to find out the error components. Okay. So, we have now when we got the estimated equations and through which we have to get the error component, then our objective is very simple. So, we like to know what is the exact value of alpha head and what is the exact value of beta head, and through the help of alpha head and beta head we get to know the error component, or we have to evaluate the error term through the help of alpha head and beta heads. So, now how do we go for that? So, since error is a residual terms and which is not supporting to the dependent variables exactly. So, our objective must be to minimize that error component. So, that means we must represent a models where every variable should be identified, means most of the variables should be explain the dependent variables. If that percentage is very less, then the model accuracy will be, you can say, very least. So, we have to prepare ourselves or we have to fit the model in such a way that most of the relevant variable must be included in the system. So, accordingly we have to design our structures or you can say systems. So, now the entire structure is nothing but E equal to y minus alpha head minus beta head x, and our objective is to get the alpha head and to get the beta head, and with the help of alpha head and beta head we have to observe the E components. Let us see how we have to observe this one. So, now E equal to y minus y heads. So, this is nothing but y minus alpha head minus beta head x. So, summation so here to get alpha head and beta head x. So, we have to minimize the error terms. So, we have to minimize the error term. The way we have to minimize the error term, then obviously we will get the best value of alpha head and best value of beta head. So, how do we go for that? Okay. So, now there are several methods through which we have to minimize the errors. So, there are methods like some of the methods like ordinary least square method, generalized least square methods, weighted least square methods, maximum likelihood estimators, maximum likelihood estimates, like this. So, many methods are there where we can minimize the error sum. So, now it is not possible to go each methods simultaneously. So, we will take a particular methods, then through which we have to minimize the error sum. Okay. So, now the easiest method for this is called as a ordinary least square methods and popularly known as OLS techniques. So, what is all about this OLS techniques? The OLS techniques objective is to minimize the error sum squares. So, now our objective or agenda is to calculate what is error sum. So, now E is nothing but errors. So, which is equal to y minus alpha head minus beta head x. So, now we have to calculate what is the error sum square. So, that means sum of the error sum square. So, that means summation E squares I equal to 1 to n. So, E I squares. Okay. So, this is the error sum square. So, which is equal to summations y minus alpha head minus beta head x, and of course, there is a I also. So, now I equal to 1 to n. So, this is also square. So, error sum square is nothing but the difference between the actual y minus the expected y. So, the difference will give you the error. So, if you will make it squares, then you will get, and it is apply sum, then obviously you will get the error sum squares. So, now through which you have to we have to minimize the component. So, now let us this is the starting procedure of this particular system. So, now our objective is here to get the alpha head and beta head. That is why we have to minimize the error sum squares. So, now since we like to get the value of alpha head and beta head, so we have to minimize the error sum squares with respect to alpha head and beta heads. Okay. So, now there are two systems here. So, how do we minimize this system? So, there are means this is typically optimization techniques. So, we have two different structure of optimization, one is called as a minimization technique and another is called as a maximization technique. So, now here we are in the process of minimizations. Okay. So, there are two standard rules to minimize the sum squares. So, now here first step is to take d summations E square by d alpha head is equal to 0 and d summation E square by d beta head is equal to 0. Okay. So, now let us call it f 1, this is called as a f 1 and this is called as a f 2. Okay. So, now the first order this is otherwise known as first order necessary conditions. Okay. So, second order sufficient condition is that. So, now f 1 1 and f 1 2, f 2 1 and f 2 2 must be greater than 0 and f 1 1 greater than 0 and f 2 2 must be greater than 0. So, that means what is f 1 1? So, f 1 1 is nothing but d summation E squares, d square summation E square by d alpha head squares. So, f 2 2 is nothing but d square summation E square by d beta head squares. Okay. So, like this f 1 2 is nothing but d square summation E square by d alpha head and d beta heads. So, now we are not going to discuss detail about this particular mathematical setup. So, what we have to do? We can get this answer through only first order necessary conditions. So, now what we have to do? We have to just minimize the sum square. So, what is d summation E square by d alpha head? D summation E square by d alpha head is nothing but 2 into summations y minus alpha head minus beta head x. Okay. So, into with respect to alpha head. So, of course, then and there is a minus 1. So, now which must be equal to 0. So, now if we simplify that implies which is nothing but summation y equal to n alpha head plus beta head summation x. Let us assume that this is equation number 1. Okay. So, now similarly, we have to calculate d summation E square by d beta heads. So, d summation square beta head is nothing but 2 summation y minus alpha heads minus beta head x, okay, into with respect to beta head. So, obviously, minus x is the extra terms which has to be multiplied in systems. Okay. So, now this should be exactly equal to 0. So, now if we simplify again. So, obviously, this is equal to summation y x y, that implies summation x y equal to alpha head summation x, okay, plus beta head summation x squares. All right. So, since equal to 0, so obviously, if we will properly structure, then we will get summation x y equal to alpha head summation x plus beta head summation x square. So, now let us call it equation number 2. Now, so if we will club these two equations, so that means the system will be now summation y equal to n alpha head plus beta head summation x and summation x y is equal to alpha head summation x plus beta head summation x squares. Okay. So, what is our objective here? Our objective is here to get alpha head and to get beta heads. Okay. Forget about the second objective of error component. So, in the meantime, we have derived these two equations just to know what is the exact value of alpha head and what is the exact value of beta heads. Okay. So, now we have two items to get and we have two equations. So, the system is a systematic one. So, that means the system is a unique one. So, it can be operated. So, what I like to do here. So, I will put this concept into matrix format. So, this is nothing but y equal to simply x beta, simply called as a x beta. Okay. So, now what is x beta here? So, x beta is nothing but you put it here like where y equal to summation y summation x y, okay. Then x equal to n summation x, then summation x summation x squares, okay. Then beta equal to alpha head and beta heads, okay, alpha head beta head. So, that means the whole system will be represented as y equal to x beta only. So, now let us assume that this is equation number 3. So, now if we will multiply, now multiplying x inverse on both the sides, okay, multiplying x inverse on the both the sides. So, what happens? So, now x inverse y is equal to x inverse x into beta, okay, x inverse y equal to x inverse x beta, okay. So, now what is x inverse x? X inverse x by matrix algebra, it is nothing but unit matrix, okay, it is nothing but unit matrix. So, as a result the value of matrix is exactly equal to 1, alright. So, that implies beta equal to x inverse y, beta equal to x inverse y. So, now the question is what is x inverse y. So, now we know what is x. So, x is n summation x squares, okay. So, we have to find out the x inverse. So, x inverse equal to adjoint of x divided by mod x, okay, mod x, okay. What is if we will put it in different structures, then x inverse is represented as a summation x squares minus summation x, then minus summation x, then n, okay. So, this is what a x inverse divided by mod a, which is nothing but n summation x squares minus sum x whole squares, okay. So, this is the entire value of x inverse, okay. So, there is a rule how to get the x inverse. So, I am not going detail about these explanations. So, you have to know yourself. So, the x inverse means if x is available and it is in square format, then obviously we will get we are able to manage to get the x inverse. So, now the system is 2 into 2. So, it is a square matrix of order 2 into 2. So, it is not difficult to get the, you can say, inverse matrix. So, x inverse is this much. So, now we like to know x inverse y, okay. So, now x inverse y is nothing but, so again we have to go for matrix multiplication, summation x squares minus summation x n divided by 1 n summation x square minus sum x whole squares into y. What is y? Y equal to sum y sum x y, okay, sum y and sum x y. So, now this is the x inverse y. So, now beta equal to x inverse y, okay. So, what is beta? Beta is nothing but alpha head and beta head, okay. So, now if we will simplify this particular equation by matrix multiplication, then we will get alpha head equal to alpha head equal to, so we will get alpha head equal to like this, this is okay, this is alpha head equal to summation y into summation x squares, okay, then minus summation x into summation x y divided by n summation x squares minus sum x whole square. This is the alpha head component. Okay. This is the alpha head component. Okay. Similarly, we will get beta head equal to n summation x y minus n summation x y minus sum x into sum y, right, into sum y, okay, divided by n summation x square minus sum x whole square. Okay. So, this is beta head component. Okay. So, now if we will simplify further, then this particular item can be represented as, you can say, summation x y by summation x square. So, this x represent where x equal to x minus x bar and y equal to y minus y bar. So, I will explain how it is transferred into this particular format. So, there is a trick to solve this particular problems. Okay. So, now since we have objective to get the alpha head and beta head. So, now you are in a position to know the value of alpha head and to know the value of beta heads. Okay. So, this is our starting point of bivariate econometric modeling. The moment you get alpha head and beta head, then the game plan will be completely different now. So, now the idea is, the basic idea for this particular bivariate econometric modeling is that we have to fit a best line, okay. Otherwise, it is called as a best fitted lines. So, how do we get best fitted lines? No, the best fitted line depends upon the value of alpha head and beta head. So, now the alpha head and beta head may be means it cannot be a constant, or it cannot be unique, it can be different with respect to different setup or different structures, because the moment we will get a particular estimated equation y head equal to alpha head plus beta head x, then obviously that model has to be, you can say, identify properly. So, that is what we call as a reliability of the models. So, the details testing structure we have discussed long back in my first 1 or 2 lectures. So, now when we have a estimated model, so we have to go first the reliability part, or that is nothing but diagnostic check. So, now once you have that, and if the model is free from this particular diagnostic check, so or it is reliable one, then you can use that model, or you can say that this model is perfectly okay or best fitted model. If not, then you have to modify by various ways, either you can redesign the model or redesign the system, redesign the data setup or redesign the technique. So, by the way you will get a particular models at the end, which one is the best model for this particular analysis. So, now once you have alpha head and beta head, so your estimated equation will be y head equal to alpha head plus beta head x. So, alpha head is followed by this one and beta head is followed by this one. Okay. So, now there is actually tricks here. So, when we particularly exam point of view, it is very difficult to go for so much derivation or analysis. There is a trick how to get the solution very quickly. Okay. So, what is our starting point here? Our starting point is here, summation y equal to n alpha head plus beta head summation x square, okay, and summation x y is equal to alpha head summation x plus beta head summation x square. So, this is how we have started our journey. Okay. So, now I think this is okay, alpha head plus beta head summation x square and summation x y equal to alpha head summation x plus beta head summation x square. Sorry, this is summation y equal to n alpha hat plus beta hat summation x, and summation x y equal to alpha hat summation x and plus beta hat summation x square. So, what you have to do? So, now let us take a first equation here. So, summation y equal to n alpha hat plus beta hat summation x. So, now what I will do? I will divide n both these sides. Okay. Summation y equal to n alpha hat by n plus beta hat summation x by n. Okay. So, summation y by n is nothing but y bar. Okay. This is what we have already discussed detail in the univariate data structures. So, now y bar equal to n cancel, this is nothing but alpha hat plus beta hat x bars. Okay. Summation x by n is nothing but x bar. So, it will be x bar. So, now our objective is here to get the alpha hat and beta hat. So, now alpha hat is only single element here. So, obviously, alpha hat equal to y bar minus beta hat x bar. So, technically there is no point to derive the alpha hat, or you have to run behind this alpha hat value. Alpha hat value we will get automatically, because we know the y information and we know the x information. By the help of y information and x information, we can get to know what is y bar and what is x bar. So, so it is not a difficult task. So, what is the difficult task here? So, now here the unknown factor is the beta hat. So, once you will get the beta hat, other things will be remain available with you. So, as a result, so you have to calculate first beta hat rather than alpha hat. So, once you will get beta hat, with the help of beta hat you can able to get the alpha hat. So, what is beta hat here? So, beta hat equal to the formula we have already mentioned. So, beta hat equal to n summation x y minus sum x into sum y by n summation x square n sum x square minus sum x whole square. Okay. So, once you will get beta hat, then through which alpha hat can be observed, Okay. So, now, so what we have to do here? So, we like to take a case here. Okay. So, we like to know what is this entire structure, how do we get this alpha hat and beta hats. So, before we go to particular example, so let me highlight here this particular issue. So, this is otherwise called as a covariance of x y by sigma sigma x, okay, or it is a variance of x, this is covariance of x. So, covariance x is nothing but simply summation x minus x bar into y minus y bar divided by n, and variance of x is nothing but summation x minus x bar into x minus x bar divided by n, n cancels. So, obviously, this is nothing but sigma x and this is nothing but covariance of y. So, it is equals sigma x means it is a square root. So, so obviously, this is okay, all right. So, now alpha hat is this much and beta hat is this much. So, that means the other way you have to represent the beta is nothing but summation x y by summation you can say x square, summation x square. So, x is x minus x bar, y is y minus y bar, x square is nothing but this particular item x minus x bar and summation x y is this much. So, if you simplify, then you will get this particular equation. So, now we have alpha hat and we have beta hat. So, now we will see how practical it can be evaluated. So, take a example here. Okay. So, we take here x series, okay, x series here, then y series here. Okay. This is sample points. So, 1, 2, 3, 4, 5 like this. Okay. So, here, so the sample points are 51, 60, then 65, then 71, then 39, then 32, then 81, then 76, then 66, then 66, then y series is nothing but 187, then 210, then 137, then 136, then 241, then 262, then 110, 143, then 152. So, that means 4 5 1 2 3 4 5, this is 6, this is 7 8 9. So, there are 9 sample points. So, this sample points is a 9s. Okay. So, these are the sample points and these are the x series and these are the y series. All right. Since x has a 9 sample points and y has a 9 sample points, that means this system is okay now. So, the model can be estimated. So, now what is the idea behind this models? So, we will assume that the model or y and x are relation means y and x are related in a linear one. So, our assumption that y equal to alpha plus beta x, and if we will add the error term, then obviously this is plus u. So, now we are assuming that the estimated model is equal to y hat equal to alpha hat plus beta hat x, okay, and where alpha hat equal to y minus y bar minus beta hat x bar and beta hat is equal to n summation x y minus sum x into sum y divided by n summation x square minus sum x whole square. All right. So, now you see here since we have a x and y series. So, what is the essential point here? For x and y, you see here this is nothing but we first need mu x mu y, okay. We need mu x mu y and another is sigma x x, sigma x y, sigma y x and sigma y y. Okay. So, this is this is mean of x, this is mean of y and this particular matrix is called as a variance covariance matrix, variance covariance matrix. All right. So, now within the given setup, so you can able to get all these items separately. So, now to solve this particular equation, so what is the essential requirement? So, essential requirement is that we like to know first what is the summation x, okay, then summation y, then summation x y, okay, then summation x squares, then summation y squares. All right. These are the requirements we like to know. So, what is summation x, what is summation y, what is summation x y, what is summation x square, what is summation y square, and finally, what is the sample size, okay, sample size. So, now in fact, I have already calculated this particular items. So, this is nothing but x series. So, sum x equal to 541, I am just filling the gap, summation y equal to 1578, okay, 1578, then summation x y is equal to 88291, then summation x square is equal to 34705 and y y is nothing but 298,712. So, this summation x square is nothing but 34705, okay, and n is here 9, n is 9 here. Okay. So, now we like to know alpha hat equal to y bar minus beta hat x bars. Let us start with the first beta. So, beta hat equal to n summation x y. So, n into 8 n is 9 here. So, 9 into 88291 minus summation x into summation y. So, 541 multiplied by 1578 summation x into summation y divided by n summation x square. What is summation x square? It is 9 into 34705 minus sum x whole square. What is sum x? Sum x is 541. So, 541 whole square. So, this is what the beta value is all about. So, now if we will simplify this particular equation, then you will get this particular equation is like this. So, beta hat is equal to 3.004. Okay. You will get 3.004 where all these informations are available. So, if you will simplify this particular equation, so you will get beta hat equal to 3.004. Okay. So, now alpha hat equal to y bar minus beta hat equal to 3.004 into x bar. Okay. So, now if we will simplify further, then it is nothing but 355.93. Okay. So, that means your final equation will equal to y hat equal to 355.93 minus 355.93 minus 3.004 into x, 3.4 into x. Okay. So, this is what they call as a estimated model. So, this is what we call as a estimated models. Okay. So, now what you have to do? So, we get to know, we just summarize what we have done till now. Okay. So, now the starting point is G. So, we have y equal to alpha plus beta x plus u, this is original format where u is error term, this is slope and this is intercept, this is dependent variable, this particular item is independent variables, all right, and this is explained items and this particular is unexplained items. Okay. So, by this process we are assuming that y hat equal to alpha hat plus beta hat x, alpha hat equal to y bar minus beta hat x bar and beta hat equal to a summation x y by summation x square, where x equal to x minus x bar, x equal to x minus x bar, y equal to y minus y bar, and x y is nothing but x minus x bar into y minus y bar, and x square is nothing but x minus x bar into y minus y bar. Okay. So, this is what we have received the final equation. So, that is called as a line of the best fitted. So, now you see here. So, the original structure is we start with the y and x only. Okay. By the way, we will get u component here, or you can say error component here. So, this is sample point. So, 1, 2, 3 up to 9. Okay. So, for every items you must have a some observations. Okay. So, now how you have to set up this particular series. So, you have y and x, means our original starting is with respect to y information and x information. So, we are assuming that y and x has a relationship, and by the way y is a dependent variable and x is a independent variables. So, now we have to fit in such a way, so that we will get a best fitted line, or that is called as a best related equations. So, now the way you have to get that best related equation. So, we have to apply so many techniques. So, here we are using the ordinary least square method. So, that we will get this best fitted line. So, now that we will assume that it is nothing but y hat. So, y hat. So, y hat equal to alpha hat plus beta hat x. Okay. So, now you will get u here. So, this is y hat structures, because y hat equal to alpha hat plus beta hat x, alpha hat is here, beta hat is here. So, put this value here, then x is there. So, for every sample x value is there. So, for every sample put x value here. So, you will get the y hat value, put x value 2 here, then obviously we will get y 2 heads. So, similarly up to y 9 head you will get it. So, now how do we get u? U is nothing but y minus u head. So, it will get call it u 1, e 2, e 3 up to e 9. So, these are all called as a error item. So, now we have to see what is the contribution of a error and what is the contribution of x towards the y. This is our basic agenda behind this particular topic. Okay. So, now there is certain problem here. So, what is this problem? So, now when we will be fitting a models y equal to alpha plus beta x plus error terms, and you will get y head equal to alpha head plus beta head x. So, this particular transformations we have applied OLS technique. Okay. So, there may, of course, there are several techniques we can you can use to get this y head equal to alpha head and beta head x, but OLS technique is the very standard technique and very easy to understand and simple to simplify. So, that is how we have to start with the OLS technique. So, when we will go deep in this particular econometric modeling, then we can apply maximum likelihood estimator techniques or generalized least square methods and weighted least square methods. So, some of the problems under this econometric modeling can be solved with this particular methods. That times OLS techniques may not be appropriate to get the best fitted line. So, there is a way how, when or what times you have to apply the GLS technique or WS techniques or maximum likelihood technique. So, here we start with first the basic level, then we have to go into complex scenario. So, now here when we will apply OLS technique, then the entire equation will transfer into y head equal to alpha head plus beta head x. OLS techniques, of course, OLS technique is the standard technique and easy to understand, easy to apply, but it has certain limitations. So, there are certain limitations with respect to its assumptions. So, we have certain assumptions before applying the OLS technique or to get this estimated lines, and these assumptions are later means a later point of times it is problem for this particular econometric modeling, and each problem has to be investigated problem. So, we will discuss detail what is the exact assumption and how this problem can be generated in this particular systems. So, these problems are very complex and very interesting also. Okay. So, now the system is means the idea is here what are these assumptions related to OLS techniques, because OLS techniques without these assumptions OLS techniques cannot be applied and you cannot get the best fitted model. So, that is what we call is y head equal to alpha head plus beta head x. Yes, it is means theoretically we are just writing y head equal to alpha head plus beta head x, but to get alpha head beta head is not so easy. There are lots of complex process or complex structure through which we have obtained the alpha and beta head. Just now we have derived the entire structures with respect to this particular alpha head value and beta head value. So, now the way we are applying this OLS, so we have to go with certain assumptions, because without such assumption it is very difficult to minimize this error sum squares, that too by the help of OLS techniques. So, these assumptions are actually divided into three parts. One part is related to error term, another part is related to independent variables, and third part is related to dependent and other items in a particular system. There are certain other items, means that items related to statistics only, not some other things. So, now we will see what are the assumptions under this particular setup. So, first assumption is that the model must be linear in parameters. Model parameters are linear in natures. So, every time we are using y equal to alpha plus beta x plus u. So, that means this model is a linear one with respect to both variables and with both parameters. So, over the complex problems, so this variable can be, you can say, nonlinear one and the parameter can be nonlinear one, but so far as OLS technique is concerned, we have to assume that all parameters should be linear in nature, but variables may be, you can say, may not be linear one. So, that means we can apply like this, let us say quadratic equation, cubic equation or logarithmic equation, it can be possible. That means y can be log y can be y squares, x can be log x can be x squares, or simply we can put y equal to like this. We can put y equal to alpha plus beta x square beta x square plus you can say gamma x. We can also fit like this way, and you will get the value of you can say alpha, beta and gamma. It is not a difficult task, but the standard assumption is that whatever model means parameters you are using in this particular setup, all parameters must be linear in nature, and for bivariate models obviously there are only two parameters in the system. One is related to supporting component, that is intercept, and another is the slope coefficient, that is indicated the weightage of the independent variable towards the dependent variables. Okay. So, this is first assumption behind this particular technique. So, model must be means model parameter must be linear one. Okay. Second, x should be non-stochastic, x followed by non-stochastic. So, that means in fact, last class I have discussed it should be random in nature. So, that means there is some kind of probability may be involved in this particular process, because we are hoping that this is the expected relationship and expected equations, or you can say whatever may be this. Since we are using the term expectations, so that means it is for future only, because the whole idea behind this particular estimated model is to go for forecastings. Okay. So, what should be in the future? This is the original structure. Within the original setup, we have to build a path through which we can predict or forecast the future one. So, that is how we are doing all these jobs. So, now means that is how we have to assume that the variables are very much non-stochastic in nature, otherwise it is very difficult to observe it, or you can say plan it. So, now the second this is the second assumption behind this particular Wallace technique. Third assumptions, your mean of error term should be equal to 0. Mean of error term should be equal to 0. So, like this. So, that means E upon u is equal to 0. So, this is mean of error term should be equal to 0. That means, you see, when we are considering mean, then obviously some items should be above and some items should be below. This is what we have learned from the standard univariate data setup. So, mean is the you can say average, or usually we consider the middle must divided into two equal parts, which is some 50% above, 50% below. If that is the setup, then obviously the entire system is more or less okay. So, now mean of the error term should be equal to 0. So, now when we will get y hat, then obviously to get error component E, we have to subtract y minus y and y hat. So, now the difference is called as a error term. So, now we have series of items through which we will get y 1 heads, x, then y 2 heads. So, like this. So, since y 1 y 2 up to y n, then y hat 1 y hat 2 like this up to y hat n. So, now for every items, so there is a error component for like E 1 for first component and for second component you must E 2, like this it will continue up to nth items. So, now since we are discussing about the average, then obviously sometimes the difference may be positive, sometimes the difference may be negative, but at the end when we will go for summation, the plus items and minus items should be equal, and if that is the case, then your system will be perfectly okay. Otherwise, this system is some kind of error. Okay. So, this is third assumption behind this Wallace technique. Then fourth assumption is that variance of error terms should be constant. Variance of error term should be constant. Okay. Variance of error term should be constant. Okay. should be constant. What is that? So, that means what is variance here? So, now we are discussing here u. Okay, u is the error term. So, we are calling it the ui. Okay. So, now we will take another error term uj. Okay. So, now there are two variables in fact. So, now what is variance? So, we start with the covariance, covariance equal to y I upon or u I upon u j. So, this is what it is called as a covariance of u I I j. So, now this covariance of u I u j can be equal to variance of u provided means if I equal to j. So, that means when we say variance of error term should be constant or you can say unique, then obviously covariance of u I upon u j should be equal to 1 for I equal to j, and this particular setup is called as a homoscedacity. This is particular setup is called as homoscedacity. That means when there is a error variance, so that error variance should be very equal like this. So, now when there are u is the error term. So, through one you can create several u's like this. So, let us say in a more generalized format u1 u2 up to un. Okay. So, this side u1 u2 up to un. So, now we have the variance covariance matrix. So, this is u11, this is u12 and this is u1n. So, this is u21, this is u22, then this is u2n. So, this is un1, un2, this is unn. That means, the complete structure is divided into three parts. This is diagonal elements, this is off diagonal, on diagonal, and this is off diagonals. So, now when we will say that variance of error terms are equal, that means these are all variance and these are all covariance. So, now this variance should be exactly similar. If this is the case, then this particular setup is called as a homoscedacity principle, and OLS techniques assumes that the error variance are equal, that means there is a homoscedacity. If the situation is reversed, or that means if the error variance are not equal, it varies with respect to sample points either in the cross sectional or something time series, then obviously it is in different format. So, that particular format is called as a heteroscedacity problem. So, we have two different game together, one is called as a homoscedacity, another is called as a heteroscedacity. So, homoscedacity is very very consistent with the OLS technique. So, that means one of the standard assumption of OLS is that, so error variance should be equal. So, that is what we call it a homoscedacity. If that is not the case, then it is called as a heteroscedacity. So, now when there is a heteroscedacity problems with the application of OLS, that means the model cannot be treated as a best fitted models. So, in that context we have to redesign the setup again. So that the heteroscedacity problem can be removed, then we will get the homoscedacity structures. So, then the model can be used for forecasting. With this we can close this chapter today. So, next class we will start with the same assumption of this particular bivariate modeling with the application of OLS technique. Thank you very much. Have a nice day.